In this video, we're going to look at exponential functions. We've talked about quite a few different functions so far in this class, so we're going to add two more functions this week. The first one today we're going to talk about is an exponential function. So this is a function where the variable, usually x, but it could be y or something else, is the exponent. So this can look like f of x is equal to b to the x, so that would be function notation, or we could have y equals b to the x. So function notation and then not function notation. So remember that b is the base. And we have a few criteria that we have to meet here. So first of all, our base b cannot be equal to 1. Because if we had a base of 1, it wouldn't matter what our exponent was. This function would actually stay the same because 1 to any power is always just going to be 1. So b cannot be equal to 1. And then also for b, if b is greater than 1, our function is going to be increasing. So our y values would be getting larger. And if b is between 0 and 1, which would mean it's some kind of fraction, then our function will be decreasing. So notice it's not positive or negative. That indicates whether it's increasing or decreasing. It's this value of b right here. So first thing we're going to do is just look at how to evaluate exponential functions. So remember, evaluate means find the value of. And we're going to look at this for a couple of different values of x. So you'll notice this is an exponential function because our exponent is the variable. So let's start by finding f of 3. So remember, in function notation, this means that we replace x with 3. So that will give us 3 to the third, which is 27. So f of 3 is equal to 27. Let's also look at f of negative 1. So remember, that means, again, we replace x with negative 1. So now our exponent's going to be negative 1. So we'll have 3 to the negative first. Remember, we can't have a negative exponent, so we rewrite this as 1/3. So f of negative 1 is equal to 1/3. Now let's look at f of x is equal to 1/5 to the x. Again, this is an exponential function because my variable is the exponent. So let's start by finding f of 0. So we will replace our x with 0, so that will give us 1/5 to the 0 power. Now remember, anything raised to the 0 power is always equal to 1. So f of 0 is equal to 1. Let's look at one more. Let's look at f of negative 2. So again, we're going to replace that x with a negative 2. Now remember, we can get rid of that negative exponent right here by simply flipping our fraction over. So we could have 5 over 1 squared, or now we can just write this as 5 squared. And that is equal to 25. So f of negative 2 is equal to 25. All right, now we're going to take a look at what the graph of these functions looks like. So just like we've done with every single function we've looked at so far, we are going to start by making an XY table. And again, since x is our variable, we're going to choose values of x. Now, we have no restrictions on what we can plug in for an exponent. We've looked at positive exponents, we've looked at negative exponents, we've looked at fraction exponents, so we could literally choose anything we wanted for x. But let's use those same values we've been using most of the semester, -2, -1, 0, 1, and 2. And we're going to plug each one of those in and get our y value. So 2 to the -2nd, remember we flip that over, that would be 1/2 squared is equal to 1/4. So when x is -2, y is 1/4. Don't forget a negative exponent means it's a small number. Then we'll look at 2 to the -1st. Again, we flip that fraction over. So 1/2 to the 1st is just 1/2. And then we have 2 to the 0 power, which is 1. And then we have 2 to the 1st, which is 2. And then we have 2 squared, which is 4. So this is our table of values. You'll notice we're not changing by the same amount every time. It's actually different amounts that we're changing by every time. And you'll notice that here, if we were to keep going, like let's say x were -3, if we plugged that in, 2 to the -3rd would be 1/8. So going back this way, the numbers keep getting smaller and smaller and smaller. So let's plot these points and see what our graph looks like. So we have -2, and then we're going to go up 1/4, so still staying close to the x-axis there. -1, and then halfway between 0 and 1. Then we have the point 0, 1. We have 1, 2, and we have 2, 4. So the graph is actually going to look like this. You'll notice I'm not crossing the x-axis. We're going to talk about this a little more in depth in a moment, but this x-axis right here is actually a horizontal asymptote, and that is at y = 0. So my graph just gets closer and closer and closer to that x-axis, but it never crosses or touches. So let's talk about the domain and range really quick. We talked about how we have no limitations on what we can plug in for x. So our domain is -infinity to infinity. But if we look at our y values, you can see, like we just talked about, we get close to y = 0, and everything is above there, but we don't touch y = 0. So our range is just from 0, and then everything's headed up to infinity. Okay, so let's go into a little further depth on why we have these horizontal asymptotes. So we were just talking about 2 to the x, and we had 2 to the -2nd was 1/4, and I showed you how 2 to the -3rd was 1/8, and if we kept going, 2 to the -4th is 1/16, 2 to the -5th is 1/32nd, 2 to the -6th would be 1/64th. So you can see that these fractions are getting smaller and smaller and smaller, but what they're never doing is getting equal to 0. So there is nothing I can plug in for x to make this function equal to 0, and notice all of these are positive, so I can't even make that function negative. So there is no value of x that will make the function equal to 0 or negative. So it can't cross that x-axis, which is why we have that horizontal asymptote. Okay, let's look at one more exponential function in its graph. This time we have a different base. This time our base is 1/2. But again, like we talked about before, I have no restrictions on what I can choose for x. So let's use -2, -1, 0, 1, and 2 again. We'll plug those in. So 1/2 to the -2nd, I flip that fraction over. It becomes 2 to the 2nd, which is 4. And then same thing with 1/2 to the -1st. I flip that fraction over, allowing me to make that exponent positive. So that gives me 2. And then 1/2 to the 0, it's always equal to 1. And then 1/2 to the first power is 1/2. And then 1/2 squared is 1/4. So this time our base is less than 1 here. 1/2 is less than 1. So this is going to be a decreasing exponential function. So let's plot these points. We have -2, 4. We have -1, 2. 0, 1. 1, 1/2. And 2, 1/4. So you can see that these actually look very similar to the ones we found for 2 to the x. They're just decreasing now instead of increasing. And you'll notice too that when we go to connect these, we are still decreasing instead of increasing. And once again, we have this horizontal asymptote at y equals 0. So my graph doesn't cross or touch the x-axis. So this means our domain and range is actually the same. We have no restrictions on what we can plug in for x. This is the line y equals 0, and our graph only exists above that, so our range is from 0 to infinity as well. Okay, so now let's look at some transformations. So I'm going to use 2 to the x for this first one because we already found the table for that. So I'm going to rewrite that over here, but if you're not sure about these values, remember we just found them a couple of examples ago. So I'm just going to rewrite them here. So we had 1/4, 1/2, 1, 2, and 4. So notice how this +3 is off by itself. It's not with the x in any way. So this is going to shift our entire graph up 3. So we'll start with our parent function. So our parent function now is 2 to the x. So let's graph that. So -2, 1/4, -1, 1/2, 0, 1, 1, 2, and 2, 4. So this is our parent function. And don't forget that we have our asymptote right here. So if I'm going to shift everything up 3, that means my asymptote also has to move up 3. So now my asymptote is right here at y equals 3. And then all of those points that I plotted are just going to move up 1, 2, 3. So I'm at 3 and 1/4. And then I'm at 3 and 1/2. And then I'm at 4. I'm at 5. And then I'm at 7. So here is my new graph with its new asymptote. This is my final here. So again, we have no restrictions on our domain. We were still able to choose any values of x that we wanted. But now our graph starts at this y equals 3 and heads up to infinity. So our range goes from 3 to infinity. Remember, we're using a parenthesis because I can't actually touch y equals 3. Okay, so I want to compare that last one with the next one. This time I want you to notice how the plus 3 is up here in the exponent spot grouped with the x. This is going to be a horizontal, a left or right transformation. And remember, it does the opposite of the sign, so this is going to move everything to the left 3. So here are the same points that we used before. Let's start with our parent function. So we have negative 2, 1/4, negative 1, 1/2, 0, 1, 1, 2, and 2, 4 with our little asymptote at y equals 0. So here's our graph. And then all we're going to do is take each of those points and simply move them to the left 3. So here, 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 and here. And our asymptote doesn't move because we didn't shift up or down. So our domain and range do not change from our original function, which was negative infinity to infinity, and then our y values go from 0 to infinity. So this was our parent function, and this is our final transformation. Okay, so the next one, I want to show you something that we haven't quite seen yet, and this is a negative in front of our x here in the exponent spot. So again, this table represents our parent function. So same points we've been using all along. But let's look at what happens to our y values when we have a negative x. So we're going to make a new table here just to show you what happens. I'm going to use those same x values of negative 2, negative 1, 0, 1, and 2. And so what we can think about, we've talked about this before, is that negative in front of the x meaning the opposite. So when I'm plugging in my exponent, I'm going to use the opposite of whatever x is. So I'm going to have my base of 2, but I'm going to plug in for the exponent the opposite of negative 2, which is positive 2, so that's 4. So in my new function, when x is negative 2, y is 4. Same thing with the next one. I have my base of 2. I'm going to plug in the opposite of negative 1, which is positive 1, so that gives me 2. I don't have an opposite of 0, so I can just go ahead and plug in 0. Now here I'm going to plug in the opposite of 1, which is negative 1, so that's 1/2. And then I'm going to plug in the opposite of 2, which is negative 2, so that's 1/4. So you'll notice this looks exactly like 1/2 to the x. So what this negative here in front of the x actually did is it's going to reflect across the y-axis. So this is our parent function over here. So let's go ahead, we'll plot that one in red. So same thing we've been doing, negative 2, 1/4, negative 1, 1/2, 0, 1, 1, 2, and 2, 4. And then remember we have that asymptote right here for now. And then this was our new function, our final, that we just calculated. So let's plot those points. Negative 2, 4, negative 1, 2, 0, 1. You can see they share that point. 1, 1/2, and 2, 1/4. So now instead of increasing, it's actually making our function decrease. But again, you can see that it's just like we flipped the graph over the y-axis. So our domain for both of these graphs is the same, no restrictions on x. And our range, they both just exist from our asymptote up to infinity, so 0 to infinity. Okay, the last thing I want to talk about in terms of graphs and exponential functions right now are base E exponential functions. So E is a number, kind of like pi is a number. And you'll have an E button on your calculator, which you may need to compute some things later on. So E is approximately 2.7. Again, it's one of those non-repeating, non-terminating decimals, so it just goes on and on forever, but this is just an approximation. So it's more than 2, closer to 3. But to graph this base E exponential function, we can do the same thing we were doing before by choosing our x values and then finding our y values. So we can use -2, -1, 0, 1, and 2. And we can plug those in, but again, we would need a calculator. We're just going to round these to 1 decimal place because we're graphing them anyway. So if you go to your calculator and you try to compute e to the -2nd and you round it, it'll be about 0.1 or 1/10. If you compute e to the -1st, that will be about 0.4 or 4/10. Now, we don't even need a calculator for e to the 0 power because we know anything to the 0 power is always 1. E to the 1st is just 2.7, like we talked about a minute ago. And so e to the 2nd is approximately 7.4. And so you'll notice when we go to graph this, it's going to look like 2 to the x. It's just going to increase quicker. So let's plot these points. -2 and then 0.1 is going up just a tiny bit. -1 and then 0.4 is not quite a half. Then we have 0, 1. And then we have 1, 2.7, which is going to be closer to 3. And then 2, 7.4, so almost halfway between 7 and 8. And we still have this horizontal asymptote right here. So we don't cross that, but you can see this looks like 2 to the x, but it's just increasing faster. Again, our domain is -infinity to infinity. That has not changed because we could still pick any value of x that we wanted to over here. And our range, our graph still only exists from y equals 0 up. So 0 to infinity for the range. Okay, so now we're going to apply a transformation to that e to the x. So you can see that I've just copied the parent function over from the last example we did. And let's look at what's going on with our transformation. So if you see, this +2 is grouped with the x up there in the exponent spot. So this is going to move all of our points to the left 2. So let's graph our parent function. So -2.1, -1.4, 0, 1, 1, 2.7, and 2, 7.4. So this was our parent function. And our little asymptote right here. So now all we're going to do is take those points and move everything to the left too. So we'll be here, 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 and here. So just move everything to the left too. And we've just shifted our graph left. That's it. So our asymptote doesn't change. Our domain is still -infinity to infinity. And again, our asymptote is at y equals 0, and everything is heading toward infinity from there. So 0 to infinity.